Let's rewind time before we had space probes, before we uncovered the brutal truth. Venus was a mystery draped in beauty. From afar, it gleamed in our skies like a cosmic jewel, bright enough to cast shadows and often mistaken for a UFO. Named after the Roman goddess of love, Venus seemed elegant, serene, almost inviting. A gentle light in the morning and evening sky, but that glow, it was a lie. A beautiful one, sure, but a deadly one too. You and I, looking up, might have thought Venus could be Earth's twin in more than just size. Same rocky makeup, close enough to the sun to be warm but not blistering. What could go wrong? Well, turns out just about everything. Beneath those soft golden clouds is not a second Earth, but a scorching, crushing nightmare. If hell had a physical location in our solar system, Venus would be it. But wait, how did something so Earth-like on paper turn into a place that can melt lead, choke out sunlight, and crush a spacecraft in minutes? Why is this glowing dot in the sky a death trap wrapped in romance? Welcome to Venus. Let's take a closer look. Venus and Earth, born at the same time, from the same swirling disk of dust and gas around our young Sunday. They're almost identical in size. Venus is just 650 kilometers smaller in diameter. The gravity? Nearly the same. On Venus, you'd weigh about 90% of what you do on Earth. Their compositions are similar too, both rocky, both with metallic cores. From a formation perspective, they should have turned out alike, but they didn't. So, what the hell happened? While Earth turned into a blue-green cradle of life, Venus veered off into catastrophe, and the clues lie in how they evolved, especially in spin, atmosphere, and internal dynamics. Venus spins backwards. Unlike Earth, where the sun rises in the east and sets in the west, Venus does the opposite. And not only that, it spins so slowly that one Venusian day lasts longer than its year. One full rotation takes 243 Earth days, while it completes an orbit around the sun in 224 days. You'd see 2 sunrises a year if you could survive long enough to see anything. Here's something to chew on. Climate models, like those run by NASA and researchers such as Michael Way and Anthony Del Genio, suggest that billions of years ago, Venus could have had liquid water oceans. Imagine that, another blue world, before it cooked itself from the inside out. Simulations even show it might have stayed habitable for 2 to 3 billion years before a dramatic tipping point. Now compare that to Earth. We've got plate tectonics, oceans to buffer temperature, a magnetic field to shield against solar wind. Venus? No plate tectonics, no protective magnetic field. Just thick carbon dioxide clouds and a choking atmosphere. The question isn't just why Venus changed, it's also when. Some believe the divergence happened around 700 million years ago, triggered by a runaway greenhouse effect or even a massive volcanic resurfacing event that buried the old Venus beneath lava. Think about that, 2 planets that started as neighbors, mirrors of each other. One became a haven, the other a furnace. Same origin, wildly different destinies. If planets can diverge that much, how secure is our own fate? All right, strap in. We're going to Venus, not to study from orbit, but to land. Just 5 seconds on the surface. Think you could survive it? The descent alone would take about an hour, like it did for the Soviet probe Venera 13 in 1981. That probe set the endurance record, 1:27 minutes before the Inferno 1. Imagine that, over 2 hours in a place with 92 times the atmospheric pressure of Earth, enough to crush a submarine. If your body wasn't inside a suit built like a tank, you'd be flattened instantly. At around 50 kilometers up, you'd first encounter the planet's thick cloud layer. Beautiful, golden, deadly. These aren't your everyday clouds. They're made of concentrated sulfuric acid. You'd smell something like rotten eggs if you could smell anything through your helmet. Visibility is near zero. It's not until around 35 kilometers down that things start to clear, just enough for your instruments to show you a hazy, rust-colored terrain stretching below. Now, touch down. The surface is 475 degrees Celsius, hot enough to melt lead, zinc, and you. Your protective suit would be working overtime. Even NASA's Venus Environment Chamber, built to simulate these conditions, struggles to keep machinery alive for more than weeks in tests. Venus doesn't give second chances. Look up. You won't see the sun. Only a dull amber glow, barely 10% of the light we get on Earth, makes it through the dense carbon dioxide atmosphere. The horizon looks eternal. There's no day or night like we know it. It's always dawn on Venus. Even movement is strange here. The air is so thick it feels like wading through hot soup. NASA simulations show wind speeds near the surface are just a few km/h, but because the air is so dense, that gentle breeze can push rocks around. Now imagine walking through that. Oh, and don't expect to breathe. The air is 96.5% carbon dioxide with a bit of nitrogen and absolutely no oxygen. In fact, try to inhale and your lungs would feel like they're being scalded from the inside. That's assuming your suit doesn't fail from the acid, heat, and pressure first. Venera 13 managed to capture the only few images we have of this nightmare. Cracked, dry plains with scattered rocks and yellow-tinged skies. That's the most we've ever seen of the surface, and it might be all we get for a while. So, still want to step out and take a selfie? Just make sure your timer's set to 5 seconds. Any longer and the inferno takes everything. Could Venus have once been a paradise? The evidence says maybe, and not just a little habitable. We're talking oceans, clouds, rain, an actual Earth-like climate. According to NASA's Goddard Institute for Space Studies, climate simulations led by Michael Way and Anthony Del Genio in 2016 and 2019 showed that Venus might have supported liquid water on its surface for up to 3 billion years. Let that sink in. That's longer than complex life has existed on Earth. So, what changed? Start with the atmosphere. Today, Venus has an extremely high deuterium to hydrogen ratio, about 120 times greater than Earth's Prydid and Prydid.Girdid. Deuterium is a heavy form of hydrogen, and this tells us something critical. A lot of water once existed and was lost. Lighter hydrogen atoms escape into space more easily when water vapor is broken down by solar ultraviolet light, leaving deuterium behind. It's like a forensic fingerprint for ancient oceans. If oceans once covered Venus, they likely evaporated slowly as the sun grew hotter over time. As water vapor is a greenhouse gas, this created a feedback loop. More heat, more evaporation, more greenhouse effect. Eventually, this triggered a full-blown runaway greenhouse effect, permanently trapping heat. Venus's lack of plate tectonics could have made things worse. Unlike Earth, which buries carbon in its crust through subduction, Venus had no efficient way to trap the carbon dioxide being belched out by volcanoes. That gas built up in the atmosphere for eons, pushing the climate over the edge. Now think about this. If the oceans were gone before the massive resurfacing event around 700 million years ago, then we may never find any physical traces of Venus's watery past on the surface. No fossilized shorelines, no dried-up riverbeds, just molten plains. But what if life did exist there? Microbes in those ancient oceans? Could they have evolved? Could they have adapted? And could anything still linger today, high above the hell in the cooler, cloud-covered heights? That question still burns, and no probe has answered it. Yet, volcanoes on Venus don't play by Earth's rules. There are no neat tectonic plates, no Pacific Ring of Fire. Instead, Venus's volcanoes are scattered chaotically across the surface, over 1,600 major ones, and possibly hundreds of thousands in total. That's more than any other planet in the solar system. So how does a planet without plate tectonics unleash so much volcanic fury? Radar data from NASA's Magellan spacecraft in the 1990s revealed enormous volcanic features, including pancake domes, flat, wide structures formed by slow, viscous lava, and vast coronae like Artemis Corona, stretching up to 2,600 kilometers wide. These structures form when rising magma deforms the crust, then collapses in on itself, releasing lava around the rim. And it's not just old activity. A 2023 study using Magellan imagery, led by Robert Herrick of the University of Alaska Fairbanks, found surface changes in the Mont Mons region that suggest recent volcanic eruptions. That's right, Venus might still be active today. But there's a twist. Without plate tectonics to recycle crust and relieve pressure, Venus's surface behaves differently. Heat builds up beneath a stagnant crust until something gives, resulting in massive planet-wide resurfacing events. Scientists believe one such event, occurring around 300 to 600 million years ago, buried most of Venus's ancient landscape under fresh lava. And here's a wild stat. Over 80% of Venus's surface is covered by volcanic plains. The surface is young, geologically speaking, but the story it tells is violent, relentless, and incomplete. No flowing rivers to carve valleys, no glaciers to scrape the land, just fire, pressure, and time. So, are you starting to see the pattern here? Venus didn't just become a hellish world, it erupted into it. Venus should be littered with ancient scars, billions of years' worth of impact craters, like we see on the Moon or Mercury. But it's not. In fact, Venus has only about 900 known craters, and they're surprisingly well preserved. That's your first clue something strange happened. These craters are randomly scattered, not worn down by erosion or tectonic activity, and they're all relatively young. No more than 300 to 700 million years old. So where's the rest of Venus's history? Where's the record of the first 3.5 billion years? The leading theory, a catastrophic global resurfacing event. According to studies like those by Roger Phillips and the Magellan radar team in the early 1990s, Venus's crust may have reached a thermal breaking point. With no plate tectonics to release internal heat, pressure built up under the surface until it all let loose in a massive volcanic outburst, flooding the planet with lava and resetting its geological clock. Think of it as the planet hitting a restart button, only it used fire. This event didn't just bury ancient terrain, it also erased nearly all direct evidence of Venus's early climate, water systems, and any possible biosignatures that might have existed. That makes Venus incredibly frustrating for planetary scientists. It's like being handed a burned book and asked to reconstruct the plot. And to make things worse, we still don't know how often these resets happen. Was it once? Twice? Will it happen again? One thing's clear. Venus hides its past under layers of lava, and it's not giving up its secrets easily. So we keep looking, probing, and simulating, hoping the next mission peels back another layer of that missing time. Venus didn't start as a furnace, but it sure became one. The culprit? A runaway greenhouse effect. Today, its atmosphere is 96.5% carbon dioxide, with surface temperatures averaging 464 degrees Celsius. That's hotter than Mercury, even though Venus is nearly twice as far from the Sun. How? It's all about trapping heat. On Earth, carbon dioxide makes up about 0.04% of the atmosphere. On Venus, it's the atmosphere. And the planet's thick cloud layer made of sulfuric acid droplets reflects sunlight but also seals in heat like an oven door. Almost none of that heat escapes. But where did all that carbon dioxide come from? Volcanoes. For billions of years, Venus's volcanoes pumped carbon dioxide into the air. On Earth, oceans and plate tectonics help remove carbon dioxide, locking it into rocks or dissolving it into water. Venus doesn't have those mechanisms, so every bit of volcanic gas just stayed. Here's a number to blow your mind. The total mass of carbon dioxide in Venus's atmosphere is about 250,000 times more than what we have on Earth. That's not just a difference in composition, it's a different planet entirely. And then there's the water, or rather the lack of it. Venus has 120 times more deuterium than Earth, a sign that it lost massive amounts of hydrogen from water vapor. The sun's UV rays broke it apart, and the lighter hydrogen escaped into space. The more water evaporated, the more greenhouse gases built up, and the hotter it got. Positive feedback in the most destructive way. The worst part? This wasn't a sudden disaster. It was a slow burn, millions of years of heating, accelerating, tipping the balance past the point of no return. A cautionary tale told in acid and carbon. So, here's a question for you. If Earth's carbon dioxide levels kept rising with no check, could we be looking at our own future in Venus's mirror? Venus's atmosphere isn't just hot, it's violent. Above the inferno lies a swirling, acidic chaos. At about 50 to 70 kilometers up, the planet is wrapped in thick clouds made mostly of sulfuric acid. These clouds reflect 70% of the sunlight that hits them, making Venus one of the brightest objects in our night sky. Beautiful from Earth, brutal up close. Winds at this altitude don't just blow, they scream. They circle the planet at up to 360 kilometers per h, completing a full lap in just 4 to 5 Earth days. That's called super rotation. For comparison, Earth's strongest jet streams reach about 400 kilometers per h only in extreme storms, and they don't wrap the whole planet. Down near the surface, the air moves slowly, just a few km/h, but don't be fooled. The atmosphere is so dense, even a gentle breeze can shove rocks and dust. It's like standing underwater, only the water is 96.5% carbon dioxide and hot enough to bake you alive. And yes, it rains acid, or it tries to. Sulfuric acid droplets form in the clouds, but the surface is too hot for the rain to make it all the way down. It evaporates long before it lands. So you get the horror of acid rain, with none of the relief. There's more. Venus has a massive double-eyed vortex over its south pole, discovered by the European Space Agency's Venus Express mission. It looks like a spinning cyclone, constantly churning at the top of the cloud layer. Researchers still aren't sure what drives it, just that it's stable, fast, and weirdly mesmerizing. Oh, and lightning? Venus has that too. Possibly caused by the interaction of sulfuric acid clouds and volcanic ash, it's sporadic but powerful, lighting up the skies of a planet where you can't even see the stars. So, ask yourself, what kind of world rains acid, hides storms inside storms, and burns you from the air down? That's not just chaos, it's Venus. Here's the uncomfortable question. Could Earth end up like Venus? Same size, similar starting conditions. What if we're just behind on the timeline? Venus is a textbook example of what happens when a planet's climate spirals out of control. Its runaway greenhouse effect wasn't overnight. It was a gradual buildup of carbon dioxide, water vapor loss, and relentless solar heating. Sound familiar? Earth's carbon dioxide levels have already passed 420 parts per million, the highest in over 3 million years. We're nowhere near Venus levels, but the trend line is headed in a direction that should make you squirm a little. The Intergovernmental Panel on Climate Change, IPCC, warns that without significant emission reductions, we could see 2 to 4 degrees Celsius of global warming by 2100. That's enough to trigger ecosystem collapse, sea level rise, and major shifts in weather patterns. And while it won't turn Earth into Venus tomorrow, it's the kind of change that nudges climate systems toward tipping points. Want a real-world example? Look at Venus's axial tilt, only 3 degrees. That means almost no seasons. Combined with the thick cloud cover and greenhouse trap, it keeps the temperature steady. And lethal. Earth's tilt is about 23.5 degrees, which gives us seasons and helps redistribute heat. But what if melting ice caps shifted that balance? Or if rising ocean temperatures slowed down currents like the Atlantic meridional overturning circulation? The danger isn't becoming Venus overnight. It's underestimating how fragile Earth's climate really is. We have oceans, plant life, and plate tectonics working overtime to balance things. But they're not invincible. So, next time you see Venus glowing in the twilight sky, remember, that used to be a place with potential, maybe even water, maybe more, and now it's just a bright warning. For all we've uncovered about Venus, the truth is, we still don't know nearly enough. Why did it lose its water while Earth held on? Did it ever have plate tectonics? Was there once life in those ancient oceans? And here's a big one. Is Venus still volcanically active right now? Even with decades of data from missions like NASA's Magellan, ESA's Venus Express, and Japan's Akatsuki orbiter, massive gaps remain. We've barely scratched the surface, literally. We've only received a handful of surface images, mostly from the Soviet Venera landers in the 70s and 80s. We don't even know the exact composition of Venus's surface rocks. Without a working lander that can analyze samples in situ or bring them back, we're still making educated guesses. Instruments like infrared spectrometers can't penetrate the thick cloud layer effectively, leaving us with radar and indirect measurements. And then there's the missing magnetic field. Venus has no internal dynamo, even though it should. Its core is similar to Earth's in size and composition. So what's going on? One theory suggests Venus cooled too slowly, never allowing its core to churn enough to generate a magnetic field. Another says it may have had one and lost it, but no one knows for sure. Upcoming missions like NASA's Veritas and ESA's Envision hope to fill in some of these blanks. They'll map the surface in high resolution, look for active volcanism, and study the planet's geology in unprecedented detail. Maybe then we'll finally understand how a world so much like ours became so utterly alien. But until then, Venus remains the biggest unsolved mystery of our solar system, a cautionary tale, a scientific challenge, and maybe, just maybe, a place with secrets still waiting to be revealed. So, what do you think we'll find next?